Sir, ma'am, shall we start? Kranti, ma'am. Pardon me, sir.
2 मिनिटं थांबा.
Okay.
क्रांती मॅडम.
Yes, sir.
Shall we start?
Yes, sir. Absolutely.
Okay. Soni madam, go ahead.
Okay. A very good morning to one and all present here in this online meet. I, Professor Soni Bhambar, on behalf of the organizing committee at Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology, take this privilege to welcome you all in the morning session of Day 6 of AICT sponsored 2-week third FDP on insights into intelligent automation, machine learning, and data science for the theme Data Science and its Applications. I welcome today's speaker for this session, Dr. Kranti Ghag from Shah and Anchor Kachi Engineering College, Mumbai. You all must be aware that ma'am is one of the participants for all of our 3 FDPs. As you all know that today's session was planned for Dr. Mansi Patwardhan, but somehow she could not join. So it's our sincere thanks to Dr. Kranti ma'am that you have accepted our request at the very last moment. Madam is an assistant professor in IT department of Shah and Anchor Kachi Engineering College. She is holding various positions in her institute like in charge of research committee member, research cell, convener in MHRD's institution innovation cell. Madam is teaching data mining for more than 12 years. In all, she is having total teaching experience 16 years. She motivates students to participate in various data mining competitions, result of which two groups of students who secured first and second rank nationally in the Data Mining Cup 2019 competition, which was held in Germany under the mentorship of ma'am. She was also one among the two mentors of the team participating in Smart India Hackathon 2020, where they won second prize for the problem statement given by ISRO. She is in charge of AI Deep Learning SIG under her institute's research cell. Madam has advised projects of social benefits such as Zero Hunger, Bombay Leprosy Project. There are 4 copyrights registered under her name. Her areas of interest are sentiment analysis and data mining, and also she has done certified courses in the same domain. She has also authored an article on the need of free software in Marathi newspaper Maharashtra Times, dated 19th November 2017, with co-author Mr. Siddharth Adekar. She is governing council member of Free Software Movement of Maharashtra, the umbrella of Free Software Movement of India. She has also volunteered in cleaning, conceptualizing, and painting Adivasi village named Zambulwadi near Karzat. This work was carried out by Namita's Fitness Hub, Seawoods, Navi Mumbai. She is reviewer in international conferences and journals. Also, a member of editorial board in international journals since 2019. She has been the resource person for various STTPs, workshops, and webinar series in her career. She has also published many papers in international conferences and journals of repute. Ma'am, may I now request you to take over and start the session?
Thank you, ma'am, and thank you, sir. So to begin with, I have shared the Google Colab notebook, which is already available on Moodle, and also the dataset link. I'm sharing it again here quickly. You can open this Google Colab notebook. We'll go with the hands-on and theory simultaneously, the presentation and hands-on simultaneously, as and when we need to switch. But in case you have not downloaded the dataset, if you open this notebook, the first link is to the dataset. So I request you all to download the dataset. Also, I'll share my screen. Is the screen visible?
Yes, ma'am.
Thank you. So I've shared this notebook link, which I've created as the author with this email. But I'll open this in the same link where everyone is opening. So we are on the same notebook, and this is as good as a new author. New person is accessing this notebook. Accessing this notebook, and then the first thing that we do, as always, is save a copy in Drive. So this will also help me to know what is the problem that you all are facing. Also on the chat, can I get acknowledgements? Is the dataset downloaded? So if the dataset is downloaded, we go ahead with the notebook. Else we go a little bit with the presentation and then come back to notebook. If you're downloading now, please say downloading so that I go to the presentation for some time. Okay. Most of you are downloaded, some of you are downloading. Okay. So I'll also give you an idea where do we have this data set. So if we look at, these are the two major resources where we get the data sets. One is Kaggle, one is UCI Machine Learning Repository. So if you go to Kaggle, you will see a lot of options over here, and you can search for anything, any data set. Like I search for sentiment and voice sentiments. So if you click on this tab, you come to know all the data sets which are available related to voice sentiment. If you click on notebooks, this is what most of the previous speakers were mentioning, that if you click on notebook, you will be able to see the actual code which people have done related to this data set. So this can be reused ahead. Also, this Kaggle provides you the platform for. I don't want to promote Kaggle or any of the medium, but these are the if I remember 15 years back when we were starting careers in data mining, That time the first question is, where is the data? Do you have the data to do the work? Now we can say we have sufficient amount of data to do the work. There are lots and lots of data sets available. So this is one of the place where you can download the data sets. This is one that is UCI machine learning repository is also an exhaustive set of data sets where you can download the data set. Now, why to do one data set? See, as we had done one hands-on on Reddit where we actually extracted the real live data and then we performed the algorithms or then we performed the machine learning task. But it's not always when you're doing some research work, when you have to present your algorithm, when you do try to do something new, and when you present that my algorithm is having accuracy of this, we can't say that we have downloaded this or this was a live data and this is the accuracy. There we need to compare somewhere with the standard data sets. So that is why we should use some of this. Also, we should do from application point of view, it should be done from real data also. So one which is from Twitter, one the example one which we did it from Reddit, which was the session given by Rocky sir. Okay, so likewise you can go for data sets. Now moving ahead, if you have downloaded the data sets, I'm sure you have got zip file, WinRAR zip. Okay, this zip file you can unzip using any of the zip softwares that you have. So you just unzip it. I have 7-zip or I just say extract here. So I've already extracted it. So you'll get a folder like this, sentiment labeled sentences, and in which you have this three data sets, Amazon Cell, IMDb, and Yelp labeled. So if these are all text documents, okay. If you're done up till here, unzipping, please punch me a yes. Unzipping is also done. Okay, Nikat ma'am is downloaded. Great. So you started downloading now and it's already downloaded, so it's easily downloadable. So to moving ahead, we'll just quickly have a look of what the data set is about. This is what my guide calls as data manthan. So one day you should spend just understanding what your data is about. So if you observe, good case, excellent value, okay, great for job on, tied to the charger for conversation lasting more than 45 minutes. The mic is great. So typically looking at this, also as from the name of the file, you come to know that this is the data set related to electronic products. Same way, or let us not explore, we'll now do with the other three. There are two more data sets which we have. Of course, the name itself speaks more. Can anyone tell me what will be the IMDb database related to? The name itself is more than enough to tell. IMDb labeled. Movie reviews. Perfect, ma'am. Because it's a movie database. IMDb. And Yelp. Okay, you can quickly open it. It's like, we can't identify right now whether you're telling it genuinely or whether you are actually opening and seeing. So you can open. You can take advantage of the situation. This is, yeah, it's about restaurants, the reviews for restaurants, different restaurants. So it is related to foods and love. You will find out words like this. Yes, perfectly correct. So let's come back to our notebook. So as we have already seen, sentiment analysis is typically identifying. It's not only this, it is more than this, whether the review was positive, whether the review was negative, or the review was neutral. Okay. So in our case, the data set has 0 and 1, which says that the review is positive or negative. Now, given these things, we can identify a new review is positive or negative. We cannot identify, like, if we had a data set, which, and there are available data sets on emotions also, which tell you about different emotions of the reviews like happy, joy, sorrow, anger, disgust. They are tagged as these words happy, joy, sorrow, anger. So, if these emotion related databases are available, data sets are available, and we use them, we can predict emotions also. But right now, we are going with a simple positive and negative. Okay, we have done one exercise in sentiment analysis, but again, we are attempting to go slightly different than what was done earlier. You can execute this first cell, which is importing of all the libraries and all. We are quite aware of most of them. And the next task is once these libraries get loaded, we'll upload all the three data sets. Now, I explicitly put this Google Colab file upload again and again, but what I observed is even if you put it just once, execute this cell, upload one file that is Amazon cell.label.txt, and then execute this cell. It gets nicely loaded. Okay. There is also one more way of uploading. If you click on this folder wall icon at the left side, you have an option here to upload, which you click over here and upload the data set. You can very easily do it from here also, but we'll go with the method that we are used to. So we will do this uploading of all the three data sets, and also at the same time we'll load them in a data frame. So you just have a look. The very first one is Amazon cell. Okay. So when you're uploading here, we will upload the Amazon cell file. We'll see the first few records. Is it loaded appropriately? It's getting uploaded. It's 100% done now. Yeah. So now you can see the reviews related to Amazon sell. These are typically, you can see again, it's the same reviews which we had seen some 1 minutes back. Moving ahead, we'll upload the second data set. That is, now here it mentions as Yelp. So I'll choose the file of Yelp labeled. And we'll also see the header of it, the first 5 records. Okay. And then we will upload the IMDb label. So once you're done with uploading all the three data sets and seeing the first 5 records, please say a yes in the chat, done in the chat. Manoj sir is already done. Vismita ma'am, 2 done. Okay, ma'am. In the time data set is getting uploaded, just have a look at the name of the data frames that we have given to each of the data. So if we observe Amazon, that is, we call it as our base one. This data set will refer me ahead. So the base one we have loaded in DF data frame. Okay. If we look at the Yelp, we have loaded in DF Yelp. Okay. Can you tell me which frame have we loaded our movie data set IMDb? Yeah, it's DF movie. Perfectly right, Nikhan ma'am. So here we are loading it into DF movie. Okay. By the time it is getting uploaded for others, or if you're getting a problem uploading, please let me know here itself so it can be solved. But you can read text files using read CSV, or there is also a command read underscore table available. Okay. In the file, if we observe at a slash at a tab, okay, at a distance of a tab, the next value that is given, that is the sentiment value. So if it is 1, indicates that the sentiment is positive. Okay, Nirbhay sir has uploaded all three and printed 5 records. Great, sir. The mic is great. So this is also a positive review. If I click on one, I see all the reviews which are positive, and these are all the reviews which are negative. So that is why we have used here separator as tab. So this will take the first value before tab as one entry, as one cell entry, and the value after tab as second cell entry. So we have two columns in our data set. One is review, one is sentiment. But if you observe, there is nothing column name like given over here. As we had seen with all numerical data sets, there used to be column names in the first line. So it is not given. So this we have a provision of specifying the column names as the keyword names, and you specify the column names in as reviews and sentiment. So what you see over here is what we have provided, review and sentiment. We have kept it same everywhere so that if we just change the name of the data frame, we will be able to do it for another data set. That is why we kept all other things same, just we have given the different data frame name. Okay, so most of you have uploaded all the three data sets. Let's have a look at the shape of the data set. The shape of the data set is going to tell us how many records are there in the data set and how many columns. So 1,000 rows and 2 columns in DF shape. So DF is related to products. Let us see what is for movies. So we have 478. Two will be there because 2 columns are there, reviews and sentiments. But we have 748 rows. Now we also want to do it for the Yelp data frame. Can anyone tell me the code for this? Try this, write the code over here, and also tell the number of records that you are getting in Yelp dataset. So we have seen for products, we have seen for movie, the restaurant is still left out. What is the frame name of our restaurant data set? Come on, how do we see the shape of this? DFEL dot shape. So you can add this cell. We can have a look at this also. Yes, ma'am. So ma'am, it's shape. So we can have a look at shape also. Okay, Jayashree ma'am has also done with all three. Great. Yeah. So in this restaurants domain also, we are having 1,000 records. Okay. Moving ahead. Typically, this is what we do in the beginning, just to understand how our data set, how it is. So we have a look at what are the no, is there any missing values? So info gives us all the details about the entire data frame. So there are no null values. 1,000 records are there, and reviews is going to be object data type, and the sentiment is integer data type. Reviews has text into it, right? So it is going to be object data inside. Yeah. Can you try quickly for other two if you want to? You can try quickly. Also, I am editing in the same notebook where the link is shared to you. No, I can't edit because I am also using it as a user. I have to edit, I have to go here. Okay. I'm not editing right now. So whatever editing I'm doing is not available to you. So I can add it as dfmovie.info, right? And similarly, it can be done for Yelp also. All the three data sets, if you see, there are no null columns. Is anyone checked for all three? If there are no nulls, just confirm no nulls. No nulls. Okay, Nikhil ma'am has already confirmed. Great. Okay, great. Great. So Nali ma'am, Jayashree ma'am already confirmed no nulls. Okay, so once it is confirmed, now we go for the next part. That is where we check the sentiments by group. Now, what do we mean by group? What are the types of value that we have in sentiment columns? We have two values, either 0 or 1. So we are going to check how many values we have for each data frame. For 0 review, where the sentiment is positive, where the sentiment is negative. Okay. So for this DF data frame, we have checked that there are 500 reviews which are negative, 0 is negative, 500 reviews which are positive. Okay. Similarly, I expect where there were 1,000 reviews. Okay, but DF movie we have less than 1,000. So let us try to do for this. The same thing, let us try to do for DF movie. So what has to be done is simply you copy paste this sentence. Okay. The code you can press on this plus sign where code is there and add this over here. And now instead of DF, we want our data frame to be DF movie. So I can just put it as DF movie and see the distribution. Okay, so that is for negative we have 362 and for positive we have 368 reviews. Is fair enough, like acceptable difference. If it was something like, sentiments of positive is only 100 and negative is 900 or positive or the vice versa, then there is a huge difference. Okay, go by ratio. If there is a huge difference, that time we need to do that is called as unbalanced data set, and where we do either oversampling or undersampling and use it and understand it. Okay. Simple printing or the next one is simple printing of the count of the reviews, how many reviews we have in each. And I'm also modifying this to check for the same visual, the data which we have got over here, the same visualized. So instead of DF, I'm also seeing the visualization for DF movies. There's nothing, nothing great we have done up till now. It's a very simple thing. Okay. If you have got this bar chart, just punch on the chat that bar chart done. Okay, Sonali ma'am is saying none, done. Nikhat ma'am done, Chetna ma'am done. Okay. Okay, Chetna ma'am is Manoj sir is getting fine. Great, great. Deshu ma'am is also done. Smita ma'am done. Okay, fine. Is anyone still like is stuck up somewhere which Nirbhay sir also done? Okay. Please pause me if you are stuck up somewhere. We can go ahead with it because now we are coming to something that is interesting and different. Okay. As of now, for the next part of the code, you see it's something like slightly huge, a long code. Don't worry about it. Just execute it. Oh, wow. Got a nice visualization of your text records of the words which are there. Uh, this is what you see as the visualization over here is called as a word cloud. So word cloud will typically take the most important words or the most prominent, most frequent words in this case and display them. So since I have done this, right now my data frame here is DFEL. I'm getting most prominent words related to the restaurant's domain. Food, place, good, great, pretty. Then you have somewhere words like burger, friendly, price, taste. Okay, very nicely presented in form of a word cloud. What you can do is just come back. Are you getting the word cloud? Word cloud okay? Can you just confirm? Word cloud okay? It might be different one if your frame is different. Yes, okay. Yes. Now what you can do is just come to the code part. We'll understand what the code is, but we'll see different word clouds first. So where you have this iterate through the CSV file for val in DFEL, just change that to DF. Just change that to DF. DF is our products domain wala data frame, right? DFEL was related to restaurants. DF is related to products domain. So just change it to DF and see the visualization. This is also one of the easy ways, or right, like when you don't have the time to go through the entire data set or you want to present what is the data set about, you want the users to understand very quickly what the data set is about, to present it in form of word cloud. So now it is related to electronics domain, products domain. So you see product, great work, phone, headset, sound, case, better. And see, as the word size and the color gets on going smaller and lighter, that indicates that word is not that frequently occurring. But if you look at this word phone, Great product. These are occurring many times. Headset. So these are very prominent words in this data set. We'll also see for the Yelp one, Yelp data frame. So Yelp data frame is, I generally avoid typing. I copy paste the words because you that reduces the chance of doing mistake on typos will be avoided typically. Oh, sorry, we are left out with movie. Yes, ma'am. As you say, yes, Chetna, you're right. So it is DF movie. Yes, Chetna, ma'am, perfectly right. So I'm now changing it to DF movies. Yeah. These are the prominent words which are in the our data set of movies. Movie, film, character, bad, acting, one, story, good, really, time, make. If you're done with all three visualizations, just punch me on the chat done so that I can come to explanation of this code. Okay, method none done. Thank you, Chetna ma'am. You can also, if you write your thesis or if you write your reports, you can do a visualization of that text and it will very clearly give you a highlight on what are the words that you have prominently used over there. Yeah, as most of you are done, we come to the explanation of part of the code. So this is our library which we are importing. That is word cloud. We have already imported it over here in the beginning. Okay. I'll not go into searching of this code, but somewhere we have imported it here. Okay. So word cloud is the library which is available, which helps us do this. Okay. No, let me complete with this first, then until okay. And then we are using the word comment words as a simple space. Stop words as we are defining the stop words which are available in the word cloud library. Okay. Now for df movies.review. So df movies.review, if you remember, is going to give us this column. Let me go to the movies one. This is Amazon. This is here. This is movies. Yeah. df movies.review is going to give us this column. Okay. And when we are reading it, it reads one row at a time. So it is going to read the first review. So that is why we will put it in a loop where we read through all the reviews one by one. Okay. So that is why for val in dfmovies.review. So in this column dfmovies.review, the first review gets loaded into this character in this variable val for the very first time. The next time when we come to the iteration, the second row will be present over here. Okay. Now typecast each val to string. So by default, what you load this review will not be a string review. It will be as a whole sentence, and that is converted into string. So when you do this str of val or str of this is typecasting of data types. So whatever is the data type of val, it will get converted to string. Why do we need to this? Because we have to separate them word wise. Right now it is a group of sentences as a whole. We want individual words to count their frequency. So then we do val dot split. So where we are going to separate out this, by default the splitting is done on space. If you want some other split mechanisms, you can specify it over here. So it gets divided into different like this entire sentence gets divided into each word and every word is there in the token. Okay. Now in tokens, so like if we look at any of the review over here, so very little music or anything to speak of. This is a very large review. It doesn't ends over here. It is dot dot means there are more words. But let us assume that we have only this much of the review. Very little music or anything to speak of. So we have here 4, 5, 6, 7, 8 words. So we want to do something for each of these 8 words. So this is the second inner loop where you are going to the length of tokens. So there are 8 tokens, 8 words available in this variable tokens right now. And we are converting each of them to a lowercase. Just that because you should, movie with M will be separate and movie with small m will be a different word if we don't do this. So we are converting everything to a lowercase. We can do other pre-processing techniques what we had discussed earlier also, like punctuations and all those things. Now, when we have done this tokens, every word is a separate word. We are joining it again. So one review, we are putting it again together. We are putting it together as a comment words. Okay, comment words may we are going on joining these words. So dot join tokens is adding all the words to this comment word. At second iteration, it will not be a second row in the comment word, but it will go on and get on adding all the text will go on get on adding to this comment word. So our entire data set is there in this comment word right now. This comment word, if you observe, we are passing as an input. 1 minute. Yeah. This comment word, if you observe, we are passing as the input over here to the word cloud function. Okay. Just you go to the last part of this, we are going giving this comment word as the input to the word cloud function. Now then what is the rest of all this? This is about layout, this is about the background, this is about what should be the stop words. So since we have defined the stop words, it doesn't take any of the stop words into consideration. Okay. And then this is our typical plotting the figure things. So you have the plot and all those axis defining and layout and all the thing what we have done already, and then finally plot.show. So this is one of the simple visualization techniques, that is word cloud. Okay, there is a, so is the arrangement of these words in word cloud be different for other outputs? Yes, even in, if you execute this again, they do it randomly. They do a layout, but the words which are important will be the same. See, right now you're getting it like this, which is slightly different than the previous one. I executed once more, let us say. See, now it is in a slightly different layer, the way it is done. Also, one thing that you can take care of in this command is, yeah, minimum font size is specified as 10. So you can't go for a size very beyond this. It won't be visible at all. So you can, if you want it to be slightly larger, if you want to use as a visualization in your college board and all that, then you can keep this font size larger also. Means these words will not get printed in that case, which are getting much smaller will not get printed. You can change this figure size and get the change in the size of the output also. So I'm getting the same image now, but in a smaller size. And you can obviously save this and use it wherever you want. Now this is the beauty because I am also a member of free software movement. So Python is a free software in two sense. It is not only free to use, but it is a, when we say we are using these libraries, these are actually the functions made by someone else and who has contributed to those. If you are interested in the research work, you can go to each of these libraries website. I saw SK Learn's website just a few days back. So if you are writing some good code and you are pushing it on Git and they really like it, it will be included in the software as well as the credits will be given to you. Your name will be there as the author. Okay. So that is what is the beauty and the advantage of open source softwares, free open source softwares. And since it is open source, see if you remember a few years back, Java was a very popular language, which is now taken by Oracle. It is still available to now. We don't have to pay anything, but you can't modify the source code, and that is the reason where it gets slightly, or Python has come up ahead because people are contributing their sources. You get a huge number. I mean, if you want to do anything, you get library for it on Python. So that's what the beauty of free software is. Free software and open source. Okay, the freedom in real sense means that the source is open. We can modify it. Okay, now coming to our typical train test split and So where we are saying that we want our data set, that is DF, to be divided into X train, X test, Y train, Y test. Okay. Uh, DF, the size, can anyone quickly punch how many records are there in DF? How many rows are there in DF? We have already printed it. Okay, going back slightly, let us see where we have printed the DF. Yeah. So you have 500 positive sentiments, 500 reviews with negative sentiments. So in total, we have 1000 sentiments. So DF data frame has 1000 records. Yes, Sonuman, perfectly right. That is, we have 1000 records in DF. Now, when we are having this 1000 records, we are doing a split. Yeah, it's 1000 with two columns. One column is review and the other column is sentiments. Yes, perfectly right, Chetna ma'am. Now, when we are dividing into parts like this, X train, X test, what was our default division size? If you remember, we were told this earlier. How much percentage goes into training? How much percentage goes into testing? If you don't remember, don't worry, just execute the next cell and quickly check it. Okay, let me check. Okay, I didn't execute this cell. That is why it is giving me an error. Just quickly execute the next cell and see it. So how much percentage has gone for training? Out of 1000, 750 has gone for training. Okay. Also, when you're giving this, see, this is the function train test split. We give two inputs to this. One is X, other is Y. Okay. In our case, X is the features are reviews, and the target value is sentiment. Okay. So that is 75%. Jayashivam says, yeah, right. That's fine. Okay. So you have got 750 as in the training. Okay. So we can see some of the records in the train. So these are, see, as it was already told, when you do a training, it is randomly sampled. So it is not first 750 records. This is 283rd record, 103rd record. This is 664th record, likewise. Okay. And there are some dots in between because it is not showing you all the 750 records. It is showing you first five and last five. Okay. Let's see the, okay. Instead of Y train, I request you to change this to X train, and X is capital if you remember. Okay. I request you to change it to X train. Oh, sorry, not X train, X test. So just change this to X. Okay, let this be there. We add it separately as a code. Along with X train, I request you to see X text. X underscore test. Yes. So I'm just putting this the same variable in the chat also, so it can be very easily accessed. X test. Yeah. So these are all the reviews which have gone for testing. So these are the 750 reviews which have gone for training. These are the 250 reviews which have gone for testing. Okay. Now once X test is done, I request you to see the Y train. Okay. Now if you look at Y train, the first record over here is 203. I'll increase the size slightly. The first record over here is 203 and its sentiment is 1. We very quickly look at X train, and if you see over here, the first record is 203, the same record, and its sentiment, this is the sentiment 1 is for this review, the best electronics available FM transmitter and all that. Okay. So this is the review available, and this review is can be very easily looked at. It is positive, and that is why here also you see in Y train this is 1. So is this visualization very clear into your mind? We have an entire data frame where there are 1000 records. One column is reviews, other column is sentiments. In X train, we have 750. In Y train, we have the sentiments for same 750 reviews. In X test, we are having 250 reviews. In Y test, we are having sentiments for the same reviews. Okay. Is this understood or any doubt? If clear, just say put a clear on the chat. So I understood it's clear. Or if any doubt, I can quickly open a notepad or something and explain. Clear. Okay, Jashi ma'am says clear. Sonal ma'am says clear. Anika ma'am says clear. Krishna ma'am says clear. Okay, most of you are saying clear. So we'll move ahead. TF-IDF is one thing which is already explained to us very nicely. So we are using the same TF-IDF. Also, I have given one more resource. Our officer had given us one resource. So I'm giving one more resource, which is where it is explained along with an example. Okay. So this is the link to it. Although I am not going into explanation of it, but just to summarize very quickly TF-IDF, what it is going to do. Or rather, I'll tell you what is the problem, basically why we need to use TF-IDF and all these techniques. The reason is really simple. See, when we are doing text process, we say typically a data set is good when you have the data set size to be large. Yes, absolutely acceptable. But the data set size large to be very large is also not a good thing. I'll give you an example. Uh, okay. So if we typically, or instead of scrolling there and wasting the time, I'll just tell you. When I did my work for a data set, a Pang and the movie review data set, and just printed the words which are available, I was getting 49,910 words. Okay, let me quickly traverse there and show it makes a sense. Okay. So this is in TF-IDF, if you remember, we had this converting our data set into matrix where we have documents, where we have words on all one dimension and documents on the other dimension. So this is first review, this is second review, and likewise. So if I'm attempting to print this, I've simply printed in my code on an Excel sheet for a movie review database. I'll also show you the review in the time this is opening. So Pang and Lee is one of the golden data sets which is used. So see, this was the first review. There are thousands such reviews. This is not the same data set that we are using, but there are thousand reviews in this. Films adapted from comic books have plenty of success, whether they are about superheroes and all that. I'm showing you this review just as a sample. Let me see now if this is opened. It's getting some time to open. Yeah, it's open now. Okay. So if you look at this, the review gets converted, gets mapped. Sorry, I don't want to change it. The review gets mapped as individual words. Okay, this is what is vectorizing, or this is what is converting our unstructured data into a structured data. As because we have already learned, our machine learning algorithms understand this format, this tabular format may hoga, so it is able to do. Otherwise, it is not. So this structure is can be easily understood. Now just look at the review which I had shown and just look at the words. Films adapted from comic books have had a plenty of success. Films adapted from comic books have had a plenty of success. And what does this mean? This word films is coming in this review for one time. The word adapted is coming in this review for two times. The word from is coming in this review for eight times. Comics for five times and likewise. Now just observe certain words that I'm highlighting. Just observe certain words that I'm highlighting. Uh, you observe this word till the time I'll answer Dr. Chenna ma'am's query. So just observe off, which is on ninth row. Just observe from, which is on third row. Just observe the, which is on 23rd row. Okay. How much percentage get assigned to validation from train set? In this case, by default, it is 25%, Chetna ma'am. But if we want to change it, we can make it to 80-20. And when we do it from research point of view, it is suggested that we should do tenfold cross validation. Okay. What is tenfold cross validation? I'll tell you. But before that, can just anyone come and tell me, or you can just try to identify what are these words? We have already discussed this. Yes, cross validation with k equal to 10. That is tenfold cross validation. Yes. In research, ideally we should do this, but right now if we do it, it will take time because it is a text data, it has higher number of dimensions and won't get executed that fast. So right now we are simply doing only one fold. It is like 80% is training, 75% is training, 25% is testing. But ideally, you should go with 10, where that is 90 training, 10 testing, another 10 for testing, another 90 for training. Can you observe what the frequency difference of these words of, from, the? Okay, thank you, Chetna. I'll show some more. It Come on, we know this term very clearly, but we should be able to get what it is. Let's see who gets it first. What are these words? Look at the frequency as compared to other words. 20, 20. Others were 1, 2, 3, likewise. Anyone? Do you remember we have studied something like stop words? Yeah, so ma'am, you got it perfectly right. This is stop words. Most of you had recollected it is stop words, just that whether I should speak or not, whether I should tell or not. So all these are stop words. Now, what is the drawback of stop words? They don't have any information into it. What is the information carried in word like in? What is the information carried like to and? इसमें क्या information होगा, right? But they are very prominent. They occur many times because that is our language style, right? So all these words will occur many times in our language, and that is why their frequency will be large. How does our algorithm works based on these values? Obviously, when this frequency is large, it is going to have an impact on the output, and that is why most of the times we remove the stopwatch. Okay, but when I explicitly said most of the times, we don't do it every time. Not is also one of the stopwords, and it is one of the most important stopwords for sentiment analysis. How is this Excel created, ma'am? This was related to my PhD work, and where I was coding in Java. That is why I didn't show the code right now. It was long back, so that time Python was not so popular. Java was open source. So I was coding in Java, where I have given this reviews. I'll show you a diagram. It's there in my presentation. So let me just go to that diagram and explain this part. Yeah. So the positively tagged reviews and the negatively tagged reviews. Let me show it again from the dataset. So this is the dataset, Fang and Lee movie review dataset, which has positively pre-processed. I have made this folder, but by default the dataset has 1,000 reviews, 1,000 text files which are tagged positively. One of the example we had already seen, that is this one, films adapted from comic books. Okay. Same way, I have negatively tagged reviews. There are 1,000 reviews like this. And when it is movie reviews, they write anything. They write stories, and somewhere at the end you might get a review like this. Okay, so there are 2,000 reviews like this. Now, when there are 2,000 reviews like this, the positively tagged reviews and the negatively tagged reviews, I've written a simple Java code which identifies the words and the documents. We can do it in our, instead of TF-IDF vectorizer, if we use count vectorizer, we are going to get this matrix in Python. Okay, so TF-IDF vectorizer, why it is needed, I was coming to that, and the same doubt you have asked. So that helps me nicely. So this is a review which we have already seen, and this creates our term document Excel. Okay. Now, why this Excel was created? Because I had done a simple coding, or I had done a classification algorithm. I proposed my algorithm, but my guide asked me, no, I want to see at every step how it is changing. So he asked me to print it to this Excel sheet, and that really helped me a lot also because from there we understood what more should be done to make it better. So when we have this Excel, probably that was the reason which for which sir told me to do this. Okay. So then once you have it like this, you can observe for word like success. I'm zooming this. Success has more or less presence in positive reviews, whereas if you observe the word success, it has very less. This is another metric. It's not the same file, but the columns are that is the first column, the word, the vocabulary. This is what we call it as vocabulary, the first column. The first column is going to be same for negative reviews, but if you observe the second column, it is not the first review which we had seen. This is the first review in negative folders. So in that reviews, films is coming twice, adapted is not there, from is coming four times. So likewise, if you observe for the word success, it is rarely occurring in negative reviews. Now this characteristics is what I used for making or for developing a classifier for words because that was the first thing told to me by my sir. He don't think like you do data mining, you use structured data. So don't think for your data as good as it is a numerical or typical column wala data. Your data is text data and try to identify how it can be done smartly, how it can be done nicely. So that is why we made this. I hope, ma'am, I have answered your question. Yeah. So coming back to our notebook. Before moving ahead with TF idea, take a 2 minutes break, 2 minutes or 5 minutes break. So can we take a 2 minutes break over here?
Yes, you can take.
Okay, fine. We'll take 5 minutes break. Okay, ma'am. Yeah. So can I start or should I wait for some time? Did we give any specific time?
No, will you to go also, na, at
Okay.
11:45?
Yes, sir. Okay, sir, I'll
Yeah.
continue
So
after.
you start, ma'am. You start.
Yes. Okay. Now the reason that showing you this matrix is we have to suppress this words, which is going to get very nicely suppressed by TF-IDF, or you can use some other mechanisms. And why do we suppress this? Because if we just look at this matrix, I just go to the end of this matrix, I have 32,203 words, which is really difficult for any system to process. It is really difficult for any system to process. Our algorithms will not work nicely. Mostly, if you observe, the matrix is also a sparse matrix. It's not a dense matrix. So the results that we get are also not going to be that nice. And that is why in this code where we specify max features is equal to 5,000, we are attempting to identify the 5,000 most important words. In this case, our features are the words. Okay? Just the way I've printed this is in a reverse format. Actually, when I mean features, these are the columns, and these the document should be the rows. But for easy understanding for my presentation, I put it like this. But the ideal way of visualization of this is the words are at the columns and the documents are as the individual rows. So one row which we get ideally is the document. So when we say 5,000 max features, features are columns. Specifying instead of that having large data set which is 32,000 or something, we are going with 5,000 words, 5,000 most important words which are there in our, which will be identified by TF-IDF vectorizer. If you give this more, the next means how do you get this 5,000 more and most important? जिसका TF-IDF value what we had calculated earlier is the largest. So the first largest TF-IDF wala word is surely there, second largest wala is surely there. It goes like this till 5,000. So you can just execute this and see. Now after this is our typical thing. So we are, we have made a TF-IDF and then we are fitting our review. So we are converting this. This we have done earlier also. So I'll not go into explanation of this. Okay, 1 minute. Yeah, this is the notebook that I was executing. Sorry, I opened it in my other ID. Yes, that error came because I was not doing. I was in a different notebook, in the same notebook in a different login. So I had not executed previous cells. Yeah. So this is the TF-IDF vectorizer created. We are printing the vocabulary where we are seeing the words in our dictionary. So when I say word vested, its index is 17881. When I say word my, its index in this TF-IDF dictionary is 1065. Also, observe what have we made this TF-IDF on. Okay, TF-IDF, if you observe, we have given the input as DF, that is our original data set. So the vocabulary is made on the basis of the original data set. But then we will have to generate the vectors for xtrain and xtest based on this vocabulary. Okay, based on the vocabulary of the original data set. So vocabulary of the original data set is learned in this TF-IDF vector. Okay, and this TF-IDF vector we are using to convert our 750 training reviews and 250 testing reviews into vector format. Okay, you can just have a look at this also. So X train TF-IDF I'm printing. What does this mean? This is the 0th review. It has these many words, and it for this first review ka first word has position 1685 in our vocabulary of TF-IDF, and its TF-IDF value is this much. So if you observe, these are like these are having good TF-IDF values. So you can observe the shape also. Earlier, our shape of train was 750, comma 1. So there was one column. In that one column, we had the entire review. So if you have observed over here where we printed, so this was our one column review. Now this one column has got divided into that format which I showed you, the Excel type wala format. So it has got vectorized. Okay, so its shape is changed to 750 reviews with 1865 columns. So it has identified 1865 as good number of features. Okay, then is our, once we have this X train, X test, we go to our, you can use any of the algorithm. You can try with different algorithms over here and we do our model fitting. Okay, we do the model prediction and up till this part we have done, right? I need not explain. Can you just give me a confirmation? It is clear up till this part. Accuracy. We have got the accuracy of model as 75%. Are you able to do the accuracy? Yes. Okay, Joshiman says yes. Can you punch me what are the accuracy you've got? I've got 75% as the accuracy. Manoj sir says yes. Okay. 82, that's nice. Indrajit sir. 84. Good. Okay. So this part is clear. Moving ahead. Okay, nice, nice. A lot of you have got good accuracies. So then we are seeing the classification reports that we have already seen. So what is the precision? What is the recall? And specifically in problems like this. So in typical traditional problems, no, where the positive class was only important, but in problems like this, where sentiment analysis, so you have two sentiments, that is positive and negative. So when you say precision for zero, it means how precisely are the negative reviews predicted as negative. When you say precision for one, it means how precisely positive reviews are predicted as positive. Both of these are really important when you consider from for problems like sentiment analysis. Means positive review getting predicted as positive is also equally important. Negative review getting predicted as negative is equally important. Sometimes, like in some problems, traditional problems of data mining, you give or machine learning, you give importance to this part. You are interested only in the positive class, typically like retrieval of records. So when you do a keyword search and you give the keyword and how are the records coming out as the output. So that time this is really important, more important rather. But in our case, both are important. Okay, going ahead, let's see the confusion matrix. We have also done this earlier. And before reading this, let us go and execute the next cell also and see the visualized format of confusion matrix. Okay, these are your predicted labels. These are your true labels. So 0 predicted as 0 is 104. So there are 104 negative reviews which are correctly predicted. There are 85 positive reviews which are correctly predicted. So that is predicted as positive and is positive also. Okay. There are 28 such reviews which are actually negative but predicted as positive. And there are, can someone tell me what is this? What does this 33 indicates? Actually, actually it is positive, but actually it is no one. Just you might be getting on this because of it is actually positive. The true label is positive, but it is predicted as negative. Now, whenever you have wrong predictions and you want to say whether it is false positive, true negative, whatever, just simply look at what it is predicted. It is predicted as zero. So that is it is predicted as negative, but that is wrong. So that is why it is called as false negative. So this is false negative. Simply for this, it is predicted as 1. 28 is predicted as 1. So it is predicted as positive, but it is incorrect. So that is false positive. So look at what is the prediction when you want to say what is false negative. So this is false negative. Yeah, you are correct, Nikatman, when you are saying this. So it is predicted as negative and it is incorrect. So it is false negative. Whereas 85 is true negative. Negative predicted as negative is true. True negative and true positive is very easy to identify. 0 predicted as 0, 1 predicted as 1. So 0 predicted as 0 is 104. So this is true negative. And 1 predicted as 1 is true positive. Okay. Yeah, moving ahead. So this is the same matrix which it was over here. Yeah, moving ahead, if we want to see how does a single record gets classified. So we have given this as a text. We are applying our same TF-IDF vocabulary learned on this text and getting it converted into TF-IDF. And then we are doing prediction from the model learned. What was our model? Our model was linear regression. We had made a model over here on, sorry, logistic regression, not linear regression, logistic regression. We had made, in this case, it's a clear two-class problem. So it is going to be logistic regression. So we have done the predictions and then we are printing the text and the predictions. Okay. Let's see what the output is. Best Bluetooth headset. So this is a positive review and ideally our classifier should classify this as 1 and that is positive. Let's try changing the word. Let's try changing it to worse. You can try with different text also. So that is worst Bluetooth headset. It is predicted as 0. So the sentiment towards this was negative. Any doubts with this topic till now or anything? I am completed for this topic. Any doubt till here? If it is clear, just let me know it is clear up till this. No doubt. Okay, fine. Thank you, Ms. Smita ma'am. Understood. Thank you, ma'am. Najit sir says clear. Okay. Okay, now yesterday in the discussion, actually, myself and Rathod sir had discussed that I'll go with 1 hour of sentiment analysis, I'll go 1 hour of intellectual property for data scientists. I keep this as two options. I have now for the time left out. I can do either of the things. I can either tell you about how to file copyrights or intellectual property for data science related thing. Or the second option is we can go more into research based aspects of the sentiment analysis itself. So what would you all like to go ahead? Can you quickly punch on the chat? We'll go in that way. Either of the things is fine for me. By the time you put it on the chat, let me show you something. Okay, this so we have already seen. One common mistake which people do, or which we did rather understood while reading the data. My guide calls this as data manthan. So you should just keep reading your text files. One assignments in the early stages was just to watch the movies randomly because I was working on a movie data set. Wait outside in the gallery where people speak review about that movie or while walking down the stairs. Just listen to what it's intervening in their privacy. But I genuinely did not misuse it. I just attempted to do it for my research purpose and uh, anything like go ahead with it. So most of you are saying research based. We'll go for the research based aspect only. That is where I've come. Uh, a simple thing. When you say most everywhere it was told to us, we should remove punctuations. Okay, we should remove stop words. Now, when we remove punctuations, why do we do all this? Why do we do this? Because we have lots of words in our vocabulary. And if we take that much of the vocabulary, it is going to be heavy for the machine learning. At the same time, it is going to be sparse. So the matrix which is there is going to be sparse. Now, if we remove this from our vocabulary, we expect that the dimensions matlab features, that is the columns will reduce and that will make our algorithm work better. Okay. So one of the proposed thing typically said is remove punctuations. Okay. So if I had a sentence which had word isn't, there was a apostrophe present over here. So it is simply suggested that remove punctuations. Now, what will happen if I remove the punctuations? It is still going to be this word isn't, okay? And it is going to be there into this term document matrix This is just a representation of the Excel file I showed you in a some time back, but in a reverse format. So here you had the terms. Now I have terms in this column format, and this is the right representation. Okay, just for understanding or summing it quickly, I had put it in this format. I can simply transpose it and get it to that format also, but it is really large. It will take time, so I'm not doing it right now. So if you have these terms over here, and these are all the documents, what does this first row indicate? I have document one where there is a word is occurring one time. There is a word not occurring three times. I have a document two, which is the word occurring not is occurring once and isn't is occurring once. I have a document three where is and not both are occurring one time each. Okay. Now, if I simply add this word as it is isn't over here, it it doesn't reduces the dimension as it is expected. The dimension is still there. The column is still there. If I could do something and map this isn't word, because isn't means is not. If I could map it to is not, this isn't ka one is will be added over here and one not will be added over here, making it one and two. Okay, the document, the matrix is exactly the same object. This is 1 3, this is 1 3, but just in this isn't is mapped as 1 2. So this has come over here as 1 2. And same way, the third is as it is. No changes done over here. Now, if you observe this matrix, this was slightly dense, slightly sparse. This has become dense now, as well as one column has reduced. Okay. Now, I just means I don't when I was doing this, I really don't understand how did this happen? How no one looked at this. Simply just it is said in traditional text mining, remove punctuations. So the punctuations were removed even in classification. But why do we remove them? Because we want to reduce the dimensions. But the dimensions is really not removed. When it was not removed, we took it as an advantage. We tried to figure out this was simply done, no great things done. Just I opened the text file, okay, and I did a control F and find out, try to identify where apostrophe is there. Control F, that is find. So I try to find out all the places where apostrophe is there. Now, what are the typical words like where there will be apostrophe? You will have isn't or couldn't, likewise, right? So what did we simply do is we mapped them to we have done regular expression, right? A regex. So we did a regex on this and simply put it as wasn't to was not. Now this was one rule. This doesn't satisfy everything. So simply scrolling through all the text or just doing control F what all places where there is an apostrophe over there. And what I got is this. So if there is a word like that, it should get converted to that is. If there's a word like you are, it should get converted to you are. But if I specify you are to you are, it will only do you are. If there was we are, it will not do. If there is they are, they will not do. So what we did is, if the word is ending with this apostrophe re, it should be mapped to this underscore means space. Okay, it should be mapped to space r. Same way, if it is like this, it should be mapped to underscore not. Okay? And then we had two publications related to this. So, most of if you want to look from research point of view, look at in the data first. Try to identify what is your data. Try to identify what is the problem in the data. When I developed my first classifier and I went to my guide and I've got 77% of the accuracy, I thought my work is done. My PhD work is done. My guide immediately asked me, what is that remaining 23%? That time I realized, okay, this is really where it is going to go much ahead. And then I started working on that 23%. Now, while doing on that 23%, this was one of the things that I came across, that is apostrophe. Another thing that I came across was stop words. As we say that removing stop words will help, but I simply removed the stop word, tried to do classification. What happened is the word good was getting classified as negative. Now this was really surprising. How come word good is getting classified as negative? Okay, I have a slide related to it somewhere in this presentation. I'll go ahead with that. But before that, while doing this pre-processing, I realized it is not only this punctuations handling, but it is also a lot of other things which are there that needs to be taken care. So typically, if there are more than this also, but these were like really important ones. This has to be done. Okay. So I wanted to continue in this direction, but again, my guide suggested if we do this, like observe how many. See, tokenization is compulsory. We have to token. It is a sentence. This is a HTML markup. It wasn't a terribly great but predictable movie. So we have to do tokenization. This is a compulsory step. But everything else to do or to not do is a option. So I can use the word great as it is. I need not convert it to a slang using a slang dictionary. Okay? So if I observe, can anyone tell me if you 1, 2, 3, 4, 5, 6, 7, 8? If we have 8 options and we decide whether to use this or not to use this, how many total combinations can we have? Like I'm asking a question where I'm saying I do one experiment where I do no pre-processing. So none of this is used. Then I do only lemmatization. So that is first experiment. That is 1. Okay, first combination was 0. This is 1. Then the next combination is 2, where I do only stemming. So that is all zeros. Stemming ke yahan pe 1 aaya. This is 0. So I do only stemming. Then 3 in our binary is 1, 1. So where I do stemming and lemmatization. 4 in our binary is stop word removal, where I remove the stop words but not do nothing else. So that is 0, 0, 0, 1, 0, 0. Can anyone tell me how many combinations do we have? Like this, how many combinations we have? Yeah, perfectly right. That is 2 raised to 9. That is 252. Perfectly right, Chetna ma'am. So we are having binary 0, 0, 0 to all ones over here. So all ones means we are doing all the pre-processing techniques. Okay. So when I had this option, my guide said, "Yeah, this is good, but it is a statistical analysis. You are not coming up with something new. You will say that this combination is the best one." But somewhere in my mind that this thing was there. It needs to be done. We need to identify which is a good combination for this data set. So this was one of my BE projects. This work was given to one of my BE projects. So they worked on identifying. I went ahead with whatever I had done till that time on the on stopwatch. That is the first of the part. And this was given as a problem statement to BE students. So where they did this part, good, and even the sequence of the functions is important. So if there is an expressive lengthening, I reduce the lengthening first, and then I do stemming or lemmatization. The sequence is important in this case. So likewise, they tried out all the different combinations like this, as we just discussed. Okay, and then they came up like out of the 256 combination, the the stopwords and the lemmatization was giving the best accuracy. It is the accuracy is there over here. Okay, that was giving the best accuracy for this data set. Understand? Now, this doesn't mean that it is going to give you the best accuracy for every data set, but gave best accuracy for this data set. So, if you're working on a different data set, typically you can try to identify for that. But more or less, if it is a text in a review domain, it should be near to this. It will not vary a lot. Slang, stopword, and lemmatization. If I'm referring to a data set which is say 20 years back, people were not using slangs at that time, right? So in that case, the slang would be obsolete. It need not be used at all. Yeah. So this was identified and which I also used. I gave a citation to their paper, which I used in my PhD work. And how does the research work goes ahead? That is what I'm trying to tell you over here. So initially it was simple, what we had done right now, or the algorithm which we executed right now, just simply like that. So after doing that, when my guide asked what is the 23% which is going wrong, we printed the reviews which were misclassified. The reviews which were not correctly classified. Tried to identify what is similar into it. Into which is the first thing what we identified is handling the apostrophe, which I've already explained. Okay. Coming to the next part, we also identified that if there is negation, okay, if the word is negative, like not good. I said the word not the good was getting the word good was getting classified as negative. This was creating a problem for us. Like why this word good is getting classified negative. But then when we read through the data set, we observed that good was coming most of the times along with the word not in negative reviews. The movie is not good, the locations are not good, the scenery is not good, the songs are not good. So more than the word good there in positive reviews, its frequency or its occurrence was more in negative reviews. Now that gave us an idea that wherever this good is associated with a negation, it should not be entered in the same term document matrix, but it should be entered in the opposite term document matrix. What do I mean by this? Just have a look at our old diagram. If a word is occurring in a negatively tagged review, like the movie was not good, I put that one in this matrix. So wherever there is a word good and this document number is 7, so I will add a 1 over here. Now instead of adding a 1 over here, what we did is since it is coming with not, we added it over here, right? So that helped us to get the word good classified as positive. But while doing this, something came to our mind is it might be like always will the word good be there? Will they always say as not good? They might say not so good. They might say not at all good. Right? Things like this could also be there. So what this example will make it clear what I'm trying to say. Just have a look at this review. Interesting and not boring. This is a positive review. Boring and not interesting. This is a negative review, right? When we try to vectorize them, vectorize means convert it into term document matrix, where you have terms written and the document may you will put the frequency. So you have this terms written, interesting and not boring. Okay, 1111 As per your term document matrix, the reviews are same. Okay, this is what my guide tried to tell me. You don't try to look a text mining problem same as a data mining problem. This is it's a specific domain, so give it a specific importance. So how can you handle this out when you have it like this? See, if I do any machine learning algorithm, the best machine learning algorithm, whatever it is going to do for this review, it is going to do for this review because it treats both the reviews as same. It doesn't treat them as different. So there has to be some long language related influence or some language related aspects which has to be taken care of. And that is what is we attempted to do using this parsing or using Stanford parser. Well, there are many parsers available. So we used Stanford parser because it is expected to be one of the best ones. So you have this word interesting and not boring. The sentence is represented in the tree format where JJ indicates is the adjective, interesting is an adjective, boring is an adjective, not is modifying this adjective, but it's an adverb. So modifier to adjective we typically call it as adjective. And this is called as this is one adjective phrase, this is another adjective phrase, and there is a key and there is a conjunction over here as and. Now when you have this, we clearly know that word not is related to boring. This Stanford parser also tells you that this is a negation. You get a relationship in Stanford parser which says that this is negation. Now, when you have this negation, then we what we did is we if not was if this review interesting and not boring. Interesting and not boring is a positive review. Positive review, if there is a word coming along with not, like in this case, instead of adding it over here, we added it over here. Same way, this is a negative review, boring and not interesting. Instead of adding word interesting in a negative matrix, we added with a positive matrix because it is coming along with not. This is called as polarity shift handling. Okay. And then the matrix became like this. So this is the interesting from this document as well as interesting from here. Didn't go into negative reviews because it come with not, it got added over here. We added it over here. So this will now very clearly classify because interesting is occurring in positive reviews, not in negative term document matrix. Now it will classify this as positive, and same way this will classify this as negative. Okay, any doubts still here? This up till what we have done is still the syntactic structure. There is one nice problem which is highlighted by most of the researchers. We have attempted to solve it partially, but it's not uh, not done perfectly. No, it's not. They say entropy is the limit. So Dr. Chetna is asking, is there any other classifier? Yeah, other than logistic regression, yeah, ma'am, there are a lot of classifiers which are available. What we have used in our exercise of which was taught to us by Rocky sir, you can attempt all of them. And what we had used over here. Okay, I'll tell you about a little bit about those classifiers also. We didn't go by any of the traditional classifiers. We proposed our classifiers and we attempted to use this itself. I'll need to open another presentation to tell you this. I'll quickly do that. This is where we were. We have already seen this, right? So, yeah, I'm taking one simple example, okay? What we have said over here is the term occurs majorly, like the word success. If it occurs most of the times in this positive documents, we'll classify it as positive. If it occurs most of the times in negative documents, we'll classify it as negative, right? So this was our simple mechanism of doing this. Like if this term is there, it is occurring majorly in positive, it will get classified as positive. Look at the term two. So green indicates its occurrence in positive, red indicates its occurrence in negative. Can you tell me how will the term two get classified? Will it be positive or will it be negative? These are like not default available in your default libraries of sklearn. Okay, this is what if you're doing from research aspect, you can propose your own classifiers. You can play around with parameters, so you can change the value of parameters and find out which are the best parameters. Okay, so but in this case, we attempted to propose our own classifiers. So yes, this will get classified as negative. That's perfectly correct, Chetna ma'am. Third term will get classified as neutral. Okay. But if I look at all these, just now comes the research problem 4, 5, 6. How do we classify this? Like this is occurring at a difference of 10. So this term, fourth term, is having its frequency as 70 in positively tagged reviews and frequency as 60 in negatively tagged reviews. There's a difference of 10. Should we classify this as positive? Or let us say not even 10. If this was occurring, say 70 and 69. 70 and 69. Yeah, Chetna ma'am is saying as neutral. Yes. So ideally, this should be classified as neutral. You should not give importance to something, Uh, ideally, we are doing is if it is exactly equal, then we are putting neutral. But if there is slight variation, we should give it a consideration. So then we initially thought of keeping it a window of 10. Okay, so we kept the window of 10, did our experimentation. While keeping a window of 10, we came across terms like this, where this term is occurring 10 times in a review and 20 times in negative, 10 times in positive, 20 times in negative. And when you're doing it like this, what happens? The word is getting classified as neutral because of the condition that we gave. But if you think logically, it is occurring twice as compared to that in positive. Okay. Now, when it is happening like this, what can be done? Okay, so we thought of instead of giving a difference kind of thing, let us give it a ratio kind of thing. So we made this as a ratio, positive by negative. Okay, so let me yeah, we made this as a ratio, positive frequency divided by negative frequency. Now for term one, just can anyone tell me for term one what will be this? If we simply take this positive frequency divided by negative frequency, will it be greater than one or will it be less than one? It will be greater than one. Perfectly right. Same way for term two, it will be less than one. Okay. Now we attempted to use the log of the value to get the sentiment. Just think, any log of a value greater than one is positive, whereas log of the value between 0 and 1 is negative. That helped us to get the sentiment. So if we have this, the negative values are larger, the positive values are lesser. So this is going to be between 0 and 1. So the log value will be negative. Same way, if the positive value is larger, positive value is at the larger, the overall the ratio will be greater than 1. So the log value is going to be greater than 1. If they're exactly equal, it is going to be log 1. Log 1 is 0. When we did this, it was working finely. But then what happens? Sometimes if it is not there in negatively typed documents, then what to do? So then we added the small value so that even if the denominator is 0 or even if the numerator is 0, the classification doesn't get affected by it. So that is how we could classify. Now, when we are doing this on frequency, the next thing that clicked my mind is why not to do it on average frequency? That was our second classifier. We did it on average frequency. Just like average frequency is the word divided by total number of documents. Okay. And the third thing is why not do it by TF-IDF? So TF-IDF is giving us the most important words in the document. What we attempted to do is find out the TF-IDF of the positively tagged reviews, find out the TF-IDF of the negatively tagged reviews, and then do this differentiation. That is what we called it as Senti TF-IDF. So this is TF-IDF of positively tagged documents. This is TF-IDF of negatively tagged document, and then put into this model as a whole. See, so this is nicely a complicated, sophisticated model, but it didn't come overnight into the mind. It went slowly. Evolved slowly, or it evolved gradually. And coming back quickly to the one problem which I was highlighting, that's the last challenge which I would like to tell. And there are many challenges like this. If you look at the data, you will come across means I at least know 100,000 things which can be done ahead. Yeah. So typically, this is one of the challenge, and it is although we have attempted to solve a little bit of it, it's still a challenge. That is called as what we did here is the syntactic structure. Okay, based on the syntactic structure, you are attempting to make the matrix, but based on the semantic structure, based on the language understanding, a visually flashy but narratively opaque, vapid exercise in style and mystification. This is about a movie review which is visually flashy. So take an example of some action movies, which action movies are typically expected to have a lot of style, a lot of mystification. But this movie is not having. It is narratively opaque, vapid exercise in style and mystification. So this is a negative review by default. But if I just read this, a visually flashy, okay, visually flashy, hai, nice, hai, right? So this part is positive, but overall the person wants to say negative. This is typical style of writing a review. When you want to say something, no, when you want to tell some negative review to someone, yeah, ma'am, that was nice, but I found this thing to be missing, but I found this thing not to be great. So that is the style of our language. Okay. So when you have these words like conjunctions like but, although, if, and they have a different impact. So I would say if a visually flashy and a nicely presented movie, that means this both the phrases have good importance. And but if I simply just go on doing the totaling of each of these sentiments, doesn't make sense. I have to treat this review like this, which means that this is one noun phrase, this is one adverb phrase. When I have a conjunction but, when I have a conjunction although, we ignored the first phrase. This is not the person what wants to tell. The person wants to typically focus on the second part. Also, a lot of language relationships, and can be identified like adjective phrase. So JJ is adjective. Opaque and vapid are the adjective. But this narratively is an adverb. Narratively opaque, narratively vapid. So this is modifying this adjective. So when I say good, good is an adjective. But when I say very good, it's adverb and adjective. So you're making a combination of it. And when you're making this combination, adverb and adjective, that time it has more impact as compared to good. So when you say good, it has slightly lesser impact. But when you say very good, it has more impact. So when there were adverbs, instead of adding, we simply multiplied the sentiments of those words. And likewise, there were around 54 relationships that we identified and worked on, but not everything can be presented over here. I think I close this from my side. If there are any doubts, anything, like a lot of doubts were asked simultaneously, I've answered them. But if there are still any more, can be asked. Also, this implementation was done in Java at that time. So I cannot, other than pre-processing. Okay. Other than pre-processing, this was done in Java. Pre-processing was done in Python. And this is how it was concluded. So every time we did one thing, we just added to the model. So initially, the baseline models were given 67% of accuracy. Our classifieds got it till 77%. Pre-processing slightly increased, but that slight increase also helps in the further increase. When we did conceptual analysis, that is what I showed you now, it gave us 88. And when we did, so typically, if you just observe now, the noun phrase, the movie was good. So the movie is a noun phrase. The headsets weren't that great. The headset is a noun phrase. A noun phrase typically carries very less sentiment information. So we just did one experiment ignoring them, and the accuracy nicely improved from 88 to 93%, which was one of the accuracies at that time. Okay. By now it is overtaken, surely by deep learning. Okay, now deep learning models go up till 97, 98, and 99%. But deep learning models have their own drawback because the models are very heavy. For deployment, the deep learning models are not that successful. For deployment, machine learning models are still very successful. So from competition, if you are participating, go for deep learning models. For application and for deployment, the thing if you're thinking of go for machine learning, and also it depends on data. Deep learning model needs a huge amount of data to give good results. If the data is relatively less, then it can go for machine learning. This is one phase where like every year we did one experiment and that went on adding to the model and came up this model which actually started from very simple model like this in first year. I have completed my presentation from my side. Over to the coordinators if there are any questions or
Yeah, thank you, ma'am. Anyone is having any questions?
actually they've asked it almost simultaneously.
Yeah.
But if still there are anything, if anyone wants to connect and I can share the Java code that I have, I absolutely don't have any issues with that. I have the Python codes for pre-processing. I can share those also. Thank you, ma'am. Thank you.
Thank you so much, ma'am, for sharing your research experience and all the hands-on that you have taken on sentiment analysis. It was really, a great, interesting, informative, knowledgeable session that you have conducted, and thank you so much for accepting our request at the very last moment. Thank you, ma'am. Please accept this virtual memento on behalf of us.
Thank you, ma'am. And it's a very nice feeling when I was seeing these mementos presented every day, and I'm seeing myself. This is very nice feeling. Thank you so much.
Yeah, I also had the same feeling. Till now, ma'am has got received the certificate for participant, and today she is getting certificate of resource person.
But I look for like I've learned a lot in all the three FDPs, and I've observed data mining changes. Like I'm teaching this subject for many years, and it changes nicely. Like it is a gradual change. So we
Yeah,
have to be updated when we are at machine learning, data mining every time. And this FDP has helped me a lot. Thank you so much.
thank you, ma'am. Thank you.
Thank you, madam.
So,
Thank you very much. Thanks a lot. Yeah, Soni
Thank
ma'am,
you,
go
sir.
ahead.
yeah. So we'll just take, sir, 10 minutes break, and Dr. Mayank Agrawal will be with us. Yeah.
Yeah, actually he promised at 12 o'clock. So we
Okay.
will meet at 12.
Okay, fine. So we'll meet at 12 o'clock.
Yes. Good afternoon, Mayank.
Yes, sir, I'm here. Good afternoon.
Thank you very much. Thanks a lot.
अच्छा नहीं हो गया मैनेज द टॉक में नॉट गो वेरी लॉन्ग प्रोबेबली 30-35 मिनट्स में हो जाएगा बट ठीक है वी कैन टेल द पार्टिसिपेंट्स
It's okay.
तो मैं भी जस्ट अभी देख ही रहा था कि और मैं क्या क्या इनको बता सकता हूँ इन मोर डिटेल्स पीछे डॉट अच्छा let me send the link again.
Soni madam, are you there?
Yes, sir. Shall we start?
So we ask
Mayank, sir.
Mayank.
Start?
Yeah, we can start.
Okay, ma'am. Go ahead.
Yeah, thank you.
So I'm
A very
just pasting the
good
link.
Yes, sir. Okay, a very good afternoon to everyone present here. I, Professor Soni Bhambar, on behalf of the organizing committee at Bharatiya Vidya Bhavan's Sardar Patel Institute of Technology, the afternoon session of day 6 of AICT sponsored 2-week third FDP on insights into intelligent automation, machine learning, and data science, where the theme is data science and its application. I welcome Dr. Mayank Agarwal from IIT Patna once again for this FDP. Sir, we are very thankful to you that you have accepted our request to conduct this session as the other resource person could not make it. So, we all know you, sir. So, without taking much time, I request you to take over this online platform and you may start the session.
Yeah, thank you, Sony ma'am, for the kind introduction, and thanks, Rathod sir, once again for all the nice arrangement. So, hi guys, this is Dr. Mayank Agarwal from IIT Patna, and I just shared my GitHub link. Those who were there yesterday, it's the same link. I have just added a new notebook on XGBoost. So kindly open your Colab and import the book. So it will be having many Python notebooks T1, T2, T3, which we have already seen yesterday. So directly jump into T6. You can just scroll down. So after scrolling down, you can see the last notebook is T6 tutorial time series forecasting with XGBoost, right? Few of the models we had seen yesterday itself. So today we will be seeing on XGBoost. The source CSV file is already there in that particular GitHub link. So you can actually open up your browser. Okay, let me share my screen. Share screen one. Okay, so this should be visible. So if you see on the left hand side, okay, so it has taken the data PJME hourly. If it does not come, then you can just paste the GitHub link as it is in the browser window. And in the browser window, you can see here the link is, this is the file, pjmerly. So you can use this file, although Google Colab should take it automatically. It took for me automatically, so should take it for you also. So at times it is best approach to, you can see the three dots here. Near the file name, you can see three dots. Just click on that dot and click copy path. Right. So by default, the path is /content /file name, but still on a safer side, it is better to use copy path. And on the copy path, you can just come on this particular line and paste your data. Okay, so this data set, I have taken it from Kaggle and even the notebook. So credits to the authors for this, right? They have very nicely explained. So hourly time series forecasting. So see, whenever you deal with time series, the unit of time can be as small as second, millisecond, or it can go up to hours, minutes, decades, and anything. Right. So a brief description about the dataset, PGM Interconnection LLC. So PGM is a company. It's a transmission organization in the USA, and it's a part of the Eastern Intergrid Operation on Electrical Transmission System, serving all these states. Right. So we have the hourly power consumption data that comes from PJM's website in megawatts. Right. So although in data science, when you deal, units are not that important. Only thing you need to ensure is all the units are in same dimensions, right? So you cannot have few units which are kilowatts, few which are megawatts, or few which are watts, right? So in that case, it is advisable to convert all of them to a standard unit. So in this case, it's already in megawatts, so we need not worry. Right, so the regions have changed over the years, so the data may appear only for certain dates per region. Okay, so just a simple theory. So we are importing the standard libraries, NumPy for processing. These all you already know. XGBoost, see, I'm importing. So XGBoost is basically a boosting algorithm. So this is basically a sub part of decision tree, right? So decision tree, if you know, for example, it will be if rainy, then don't go out. If not rainy, then maybe you can go out. So decision trees makes various kind of trees actually. Fine. So that is just that algorithm. And then we have our standard scikit-learn library. This XGBoost plot importance and all we will see how this is very important feature of XGBoost. So XGBoost, it's people say it's like a magical algorithm because the overhead is less, right? Open source implementations are available in C, C++, Python, and virtually every programming language, right? And this is just for styling. So even if you skip the line, no issues will be there. Okay, so let me try to see this file and show you how is the data arranged. PJMERly. See, whenever we do such kind of tutorial, however ease pandas and all may give, it is always better to open the file in Excel and then just see. Just let me expand this. Okay, so this is PJME and MW stands for megawatt, and we have a date time here, right? So now if you see the date time here, so 31/12/2002, and you can see this is 1 a.m., right? Early morning 1 a.m. And since it was told that this is an hourly data, so this goes like 31/12/2002, 1 a.m., 2 a.m. So at 1 a.m., when the timestamp strike, they took the total consumption in megawatts, so that was 26,498, right? So and a day has 24 hours, so you can see here. So let us try to search 31/2/12. So this, right, find all. Oh, so there may be too much finding, sorry. So let me do find next. So find next, let me just go from 2 up till 24, right? See, for this particular first entry, since it's beginning from 0100, so we don't have an entry for 0000, right? So you can see the count is 23. I think the font is too small, but the count is 23. So let us check for, okay. So you can see there are some missing data also. So for first, it has only the count for a single hour, right? Then for the 30th, let us see. The count again is 23, right? Actually, the count will be 23 because for the next day, it goes to the 00 of next day. So I think, see, 31/12/23 hours, because when the clock strikes 12, it basically becomes 01/01/2003, right? So it basically becomes the 1st January of the next year, right? So you can also assume it to be like 2359. So now we have 24 data points here. Similarly, for the date of 31st, when I select, I have a count of 24, right? So now you get a feel, okay, how is the data organized and how is the data arranged, right? So let us close this file and I can press Control down arrow key. So you can see there are 1,45,367 rows, right? So we have a very good data set, right? And you can see the last date is 2nd of January 2018, 2nd of January 2018, and we started with 31st of December 2002. So roughly we have like 16 years data. So okay, we begin directly from 2003. 18 minus 3 plus 1. Okay, that's fine. So we have a huge data. So we can now close the screen and back to our collab, right? So the standard PD reading code. So as I said, index call 0 is because we want our timestamp to remain as the index, right? If I don't give index call equal to 0, pandas will make its own index 0, 1, 2, 3, right? So we want our timestamp to be, so let me open this timestamp in the browser itself. View raw. Right, so this is our date time and you can see this is a timestamp and this is the value, right? So what we are doing, we are saying pandas ki okay, make the column 0, right? So first column, this has index and I'm asking this to parse date. Again, this is a very important command, right? So if you don't give parse date, so you can also specify this in terms like date time, the column name, or let us now keep it for 0 only, right? So you can refer the column 0. So when I say parse dates, so what will Python do? Pandas basically will think, okay, this is a date timestamp format. So now you can do more processing on it. So in this example, we are going to do a really good processing on this. We will actually split this particular timestamp into year, month, date, then hour, minute, and second. We will just shortly see this. Right. So as a standard approach, because there is a lot of there is a possibility that there will be null values here, right? So you can see this PJME megawatt, right? Our column name is PJME megawatt. So it says there are no null values, right? Advisable to use the dot sum function, because if you use only the is null parameter, then it will show you the whole table, right? So it will say false, 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 false. It makes no sense, right? Because you have 1.4 lakh rows. So just keep it sum for timing, and it says okay 0, and it can see the data type is all integers, right? So you are sure that there are no nan values, there are no string values, etc. Right? Now, just for information, right? So you can also see from here we have this many entries, and see, since you had said parse date is equal to 0 and basically parse the dates, it basically says you from what range to what range you have the data. So you can see from 31/12 1 a.m. to 2nd of January. Okay, just a minute. So this is the standard data information, and now you can see the description. See, whenever you do a describe function, it gives you really good statistics. I'm not sure whether okay. So how many rows we have? The most important thing here to see is the standard deviation that you observe. See, the higher the standard deviation means the data is distributed very widely across the mean. So you can see from here itself that the prediction will be challenging in such cases. Let's say my standard deviation is very low. So in that case, the data is quite uniformly distributed, and in that case, you can get a good prediction, right? So since the standard deviation here is quite high, so let us see how our model projects. Right, so this is just a standard color palette. So given the variable name color pal, and these are some hash values, so RGB values basically. And this is just for demonstration. You can also use by default matplotlib, so it may appear blue and all. So you can see we have the date time. As we know, we have the data from 2002 to 2018, and our plot goes from 20,000 to 60,000, right? So now we do a standard train test split. So I downloaded an image actually, train test split. I hope by this end of the tutorial with you must have already seen, but at times people do get confused between train test split. So let me do x train x test. Okay, x train, how the actually split happens. Okay, not getting a good image which I had. Let me just show you an image which I had downloaded yesterday. Desktop. Hope it is visible, right? So whenever you divide the data into test and train, so remember that most of the machine algorithm, okay, pausing, resume. Shift tab. Okay. So most of the algorithm, what they do, so for example, we can have multiple column as a feature, and response column is basically our target column. Right, so whenever we try to split the data, so we have the x train, x test, y train, and y test. So what happens, the entire data set basically split into 4 parts, right? So x train corresponds to y train. So you can see the yellow and the orange one. So in this data set, which is comprising of 5 rows and 3 columns, so we basically make 4 kinds of split. So let's say we do a 70-30, right? 70-30 when you do, so the 70% gets for the training. So it will train the model on 1, 2, 3, 4, 7, 8. And the corresponding Y train will be 2, 12, and 56. So using these 3 rows, your model will actually be trained, right? And using the X test, right? So whatever it has learned, right? So once it has learned this 1, 2, 2, 3, 4, 12, it will try to check the value on 5 and 6, right? So then from 5 and 6, it will predict the value. And since you know the real value of Y test is 30, and from this 30 and from the prediction that you have learned, the model determines the accuracy. So this I feel is a very hello world kind of figure, so that we can visualize what is train and testing, right? So this is done. So without wasting much more time, so now what I have done, 1 January 2015, right? So I'm taking this as a split date. See, we have the data from 2002 till 2018. right? So we have roughly 16 years of data. So normally what we do in 16 years of data, we do a 60, a 40 or 70-30 train test split, right? So I am saying ki, okay, I want to split the data on 01 Jan 2015. So let us see what will be 2015 0101. Okay, should have come here. I don't know why 2015. Okay, the browser did not load it. Let me open that in Notepad. So basically from 2002 to 2015, we are splitting the data. So if you can see less than equal to split date, we are having it's a training set, and more than the split date. So data after 1st January goes to the test set. So roughly from 2002 to 2015, we are having our training cells. So let me insert a code block here. So you can just see how the train looks like. Okay, not defined. So sorry, I did not execute this block. And now I'm executing this block, right? So you can see the split date was 1st January 2015, right? So we have our training model is less than equal to the split date. So we begin from 2002 and go up till 2014, 2nd of Jan 2014. Okay, this is okay. Let me just check. So let us check this particular date here. Should have been 2015, or that might be some missing values. Okay guys, let me open this in Notepad, would be far more easier to search. 2015. Okay, and what was our split date? Split date was 1st of Jan 2015. So let us check the first date. Okay guys, so this is the answer. See, that is why the last values are appearing as this. See, for example, 2014, the last date that you get is this one. And from 2015, you directly begin from the month of December. So there is some missing data probably in the data set that you said, right? So you can see for the last data of 2014 is here, and the 2015 data basically begins directly from the month of December. So when you see in this case, see, this is how you need to look at the, because see, for example, when we were splitting something on 1st Jan, the last data should have been on the last month of 2014, but right, we have some missing data, but it's okay. Underscore is just like a garbage variable. So underscore is something when we are doing some operation, and underscore means okay, because it requires something on the left hand side, we are using it like a garbage variable, but we won't use it further. So this again is just nothing but okay. So when we decided to split on the training and the testing set, this entire thing becomes the training, which is up to 2015, and after that it's the test set, right? So that is fine. See, now this is a very important function, create feature, and we are taking data frame as the input. So just let me run this and this one. See, for both train and Y train and X test and Y test that I explained here. So what we are passing the training data and labeling it. The label basically, of course, is this one, PJME. So no issues. So now see, our timestamp is in this format, right? It's a long format containing the year, month, date, hour, minute, and second. So see, now what we are doing based on this index, based on the training data, we are splitting the time into date, hour, day of the week, quarter, month, year, day of the year, day of the month, and week of the year, right? So since basically now you will just see the importance of this particular thing. When we had initialized parse date as 0, right? This means because pandas is a very powerful date time library, right? So if you see from the data, it does not provide you what is the day of the month, right? So for example, let us come back to our create function. So day of the week, right? So we don't have any information about the day of the week, whether it's the first day, second day, third day directly from it. But pandas library will make this possible. So we will just see in a while how does that happen. So let me just add a code piece here. So just for your knowledge, let me just display the value of extreme. Now you just see what happens to X train here, and just let me move this part here. I don't know whether it should take. Okay, so it already splitted here. Let me again do this part. Okay, this is done. This is done. Okay, this comes like this only because we have actually split this. So now you can see this entire date. So for example, initially date time was 2002 12 13 0100. So this is our 0100. So see, this happens when you do with time series. At times you have to split the data to such a granularity so that you can get a better prediction. So now you can see R is 1, right? Because R is 1 here, day of the week. So it is taking 31/12. It is taking as first day of the week. This is the fourth quarter, right? Month is 12. It directly picked up from this. Year, it can pick up from this. Day of the year, right? 350, 365th day, right? Because this is December 31st. So it becomes the 365th day of the year. Next, you can see like we have 1st January, right? So 1st January becomes the day 1. And day of the month is 31st, that you can pick up directly from here. And week of the year is 1. Okay, strangely, it is taking that as week 1. It should have been 50 seconds, but okay, this is the pandas data series library that it takes. Strangely, all the day week of the year is 1. Probably we need to look more into this feature, right? So we now split it into train and test. That is our standard implementation. X train we have already seen. Now let us see what is Y test, right? So this basically is your test data set. So you can see it is 31,000 rows. And now we are creating the standard XGBoost model. There is a feature here which is known as early stopping round. So what happens internally, every ML or a AI algo, right? It calculates a loss function internally, right? So loss function is basically gives you a parameter saying whether are you improving the model or how the loss is getting reduced, right? So if you remember yesterday we were running epochs and LSTM and other algos. So there was a term that comes as loss. So technically the loss should reduce at every stage so that your model becomes perfect. A perfect model will have zero loss, but that does not happen theoretically. So what happens when we say ki, okay, if you can run as many number of times as you want, but after 50 rounds, if you are seeing that the loss is not getting reduced significantly, then you can stop the model. This is how we save on the computations, right? Right now the data set is really small, 1.4 lakh is nothing, right? So when you have a billion entries or few million entries, then early stopping becomes a very important feature, or your model will keep on running and just have a very small loss error rate of 0. I mean a very small reduction in error, 0.001, 0.002. In that case it works, right? So right now let us keep verbose as true. Let us see what happens, right? So see it, okay, let me just complete this training. So it's a will train until validation underscore one RMSE, right? So it is taking the error metric as RMSE hasn't improved in 50 rounds, right? So see now it has a validation RMSE of 25,000 in the first round. In the second round, it became 23,286, right? So of course, which is good. RMSE should be as low as possible, right? So this it will, okay, it will then see, okay, 18,000, 15,000, 12,000, 11,000. And now you can see for the 50th round, right? It had 3813. Okay, let me, sorry, zoom it. I forgot to zoom that day also. So it had 3813 for the 49th round, 3809, then 3808. See, now since the RMSE reduced by a significant amount, right? A unit of 1 is a very significant amount in terms of MLAI and all. So it keeps on executing it, 805, again an improvement, right? So if you can see the error actually increases here. After 50 rounds, 3809, the error actually increases. So at times this also happens. So if the model sees that the RMSE value is getting increased, it may actually then in the last give you the result at what it obtained the lowest RMSE, right? So if I show you in a paint window, so it happens at times. So for example, let me just take the brush, right? So as you increase the number of runs, right? This is the number of runs that you are trying, right? Initially the error will be very high. Usually the error falls in like this criteria, right? But at times it happens, this is the ideal scenario. But for example, it may so happen that your model may have a reduced error and suddenly it may happen that the error actually goes on increasing also. Right? In that cases, when you do an early stopping, the model will feel, okay, this is the optimal point at which you are getting the lowest error. So internally, the model reconfigures itself and says that, okay, this is the optimal point. So it may have n equal to 60 or n equal to 70. That is trial and error basis. And then you need to train your model on this particular value, right? Even though, for example, the ideal case is like this, a model should train and go towards zero. So what happens, you can see in this particular window, right? In this particular time range, the error reduction is not that huge, right? So whenever you do these kind of algos like LSTM, GRU, CNN, these are expensive and super high in computational power. Right. So it is advisable that instead of reducing the error by such a thin margin, you basically stop your computation at this point, right? So that you save on the computation resources. So this is usually the error graph that we get. Okay, let us see how many times did it execute. 3 7. So by, for example, if you can see here, we begin from iteration 1 and we went till iteration number 199, right? So you see the validation is 3753, but it says stopping best iteration because now the model is seeing that roughly. Now you can see in the last 3 720 3719 3715, and roughly it is around the same thing. Now it is increasing 3752 3759, right? 3762, the error is getting large, and finally it saw that okay, it is increasing only. So it automatically picked up the best validation. It says validation 1 RMSE is 3712, right? So when I see 3712, this will give me the least value of RMSE in all the 199 runs. So let us go to RMSE 149, sorry, iteration 149. Let me see, iteration 149 is here, right? So you can see RMSE is 3712. So your model will, even though your model has run 199 iteration, it will pick the model that it had obtained at 149th iteration because it gave you the least RMSE. If you want to verify, let me just write a small script near you only.
So there are
So
two message in the chat section.
okay.
Vismita is getting some error for verbose, and Dr. Chetna is saying that PJME hourly.csv file, it is not able, she is not able to download that.
Acha. So Dr. Chetna, you can do one thing. You just open up your Chrome browser and just go to my collab library. Okay. So Dr. Chetna, in the chat box, if you want, I will just type again. I think it's there. You can just scroll there. Open this collab thing, right? Just click on this PJME hourly dataset, right? And click on the download button here, right? You can just see the download button. So let me just show it for you. Sometimes it opens in the browser. In that case, just do a control S. So control S will ask you for a save as, and then you can save the file locally. Let's say you are saving on your desktop. My it already had, so it is asking me for a replace. So once you open and save that file, come back to your collab window and click on the drive icon. See on the left pane, you can see the drive icon, right? And this is the upload button, right? Just so that it does not replace my original file, let me just rename this file. Let me make it underscore 2. So Dr. Chetna, you don't make it underscore 2. You keep it the same file. Just upload the file. It will give a warning. Just click OK. So you can see in the bottom it is uploading the file. And for the other candidate, verbose equal to true should work. Just check that whether you have written true with a T capital, right? And don't put the quotes around true. So true is just capital TRUE, right? Because if you see in Python, so if I just print true is basically a boolean, right? So print true comes as true, but if I write TRUE with a small one, right, it may pop up an error, right? True is not defined. So the other candidate may be requested to keep true as with a capital T, right? So because the type of true is boolean, so when you see type of true, it will say as boolean, right? But there is no type associated with small true. Strange thing computer science engineers design. See, true is not defined. So Dr. Chetna, see, for example, since I uploaded the second one, right, this is how the file will appear. Click on the three dots, do a copy path. Once you do a copy path, you can just, in the second line of the code, you can come here and paste your path, right? And then your error will go, right? So I am not pasting and executing this cell block because it's already been in the memory, right? Hope Dr. Chetna, your doubt should get solved. If not, please ping back in the chat window, and Dr. and Renuka ma'am, you can just inform me if her error is not solved. Okay, let me write a
Doing
small.
that, for Vismita, for that verbose error, she said that it is saying boost error, boost error. Sorry.
Okay, XG boost error, if it is coming, then you can, Smitaji, you can actually try to run everything from the start, right? If you are getting an XG boost error, just check whether all these library executed correctly for you or not, right? If there is an XG boost error, it must have come in this line itself for your execution. And if it exists, then add a code line. So let me just do a simple install xgboost in collab. There will be probably pip install xgboost. I think that will be the library, right? So you can try this one, pip uninstall xgboost, and okay, this is actually trying to install a specific version. I think these two commands should work. So Smita, right? Smita ji, you can try these two commands in your Google Colab. Just give an exclamation pip uninstall xgboost. So that will uninstall your xgboost, and this you can move upstairs. Right? So first uninstall xgboost, then install xgboost, and then you can just import all the libraries. I think it should work in my opinion. This is the only thing that computer science guys do, right? They restart things and magically it works. The principle of restart. Dr. Chetna, I hope it's working now for you, right? So I was on to writing the script. So just to be very sure that the model has selected the best one. So let me invoke the bash shell. So let me just save this as a CSV file, rmse.csv, and let me open this in Excel. Because the separator here will be colon, so I have to open it in a different manner. Data from text rmse.csv delimited, and I'm specifying as colon, right? So let me do a finish, take it in this. So this is our rmse that we need to check. Waiting for this, scores 1. So if you see here, validation underscore 1. Okay, just a minute. Okay, so we were having an early stopping of this. Validation is this 3712. Let me just check the scores. Okay, this is 25,000. Fine. Right, so let me sort by this column. So when I do a sort by smallest to largest, right? So now you can see when I sorted in Excel by smallest to largest, I basically got 149, right? 149 is appearing twice because if you see here in our Excel, so 149, the iteration itself, Where is 149? 149, the iteration itself, and in the end, it repeats the same line, right? So you can see, as I told you, in the error graph, it may sometimes increase, right? So we basically got this particular case. The error came down to a level and then the error started actually increasing, right? So model in the end, what it does, it stops and then picks up the best index for which it got the best results and then trains your model on that particular value. So this is done. Now let us remove this particular thing, remove the cell, and see what happens here. Now if you see your features, plot underscore importance, so there are many tests like a KIK is there, information gain is there, ID3 is there. So there are many important such tests that determine which is the most important parameter. Now if you see this feature engineering graph, we have day of the year, hour, year, week of the year. This is the same thing that we did with the this feature selection, right? So we converted all the dates into this format, and basically if you see, these are the same parameters here, right? Hour, day of the week, quarter, month, year. So for each of these features, right, we have 1 2 3 4 5 6 7 8. We have 8 columns here. So what does plot importance does is it determines the 1 2 3 4 5 6 7 8. For all the features, it actually helps you to determine that which parameter or which column or which value basically had the highest significance or highest importance in determining the output prediction, right? So even if you see, since we have an hourly data, right, it makes sense that the day of the year, right, which day it was, it makes hour and year as automatically is coming from the top to bottom. And if you see this, right, we are doing an hourly prediction. So closer the data is to hour, for example, hour still ranks 2, right, because it's just a mathematical calculation. Hour automatically comes as second, because if you see intuitively, if I give you quarterly data and I tell you to predict hourly, right, it will be a humongous task, right? Similarly, if I give you a month of the data, right, okay, this is monthly data and try to predict the hourly rates, it automatically will be a very bad prediction. Consequently, if I am saying you, okay, I'm giving you an hourly data and now predict the hour data, it always makes a sense, right? And day of the year, again, I think this is day 1, day 2, day 3. So usually combination of first two parameters gives you enough validation results, right? So this is the importance of plot importance, and you have to include this, right? So let me go to the start again. You can see here we have here from XGBoost, right? So XGBoost library itself has the plot importance and the plot tree, because eventually XGBoost derives from decision tree that makes a large number of trees in the background. So this gets here, and the forecast is usually the easiest part. All right, so we make the test and then we train the model, we use the prediction. So any algorithm you use, this part is usually the most easiest part, right? We call it as like script kiddies. Script kiddies means a 4th standard guy can just click this button and get prediction. More important thing, whenever you do, always remember it's not about the algos, it's all about how you train your model. Like in this particular case, if we had not split in this particular granularity, the prediction would have been really bad, right? So now back to this. And so for example, if you can see, the blue is basically the original data, and you can see this is the predicted data, right? So from the prediction, you can see though the model actually captured the trends here, right? So there was a trend in this data, but it was still far away from predicting the peaks, right? And predicting peaks is always usually difficult and a very challenging task, right? The standard, if you see in the middle section, right, this was predicted quite well actually. So let me just show you in annotation. So if you see this particular kind of average thing, right? So on an average, these guys get actually predicted well. But you know, the peaks are the most challenging part, and the peaks usually are very difficult to predict, right? That goes with almost every algorithm. So as such, nothing new here. So now let us look at first month of prediction, right? So our data basically began from this 31st December. So we will see for the first month. So the lower bound is 2015, 1st of January you can see, and the upper bound is 2nd of February. Oh, sorry, this is by US date format. So we have the month first, MMDD. So from 1st January 2015 to 1st February 2015, right? And we are just setting up the y limit so that the graph looks proper. So let us see this one, what it comes. So now you can see this is just for 1 month, okay? 1st January 2015 to 1st February 2015. So now you can see the prediction is in orange. So we can say the prediction is okayish, not very good, as you can see in this particular region, right? Let me just annotate. So in this particular region, the prediction is not good, right? While in this particular region, the prediction actually came quite good, right? Almost you can see an overlap. Again, in this case, it was quite of an average, right? See, this is the best prediction, right? If you can see this particular line, right? This is the best prediction. Almost it overlapped. So this was just for the first month. Let me remove the annotation and now plot the forecast with the actuals. Again, so here what I'm saying, 1st January 2015 to, I think this is, I always get confused between US date because we see so much of DDMMYY. This basically is, I think, for the 8 months. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, and 1, 8. So this is DD, and YY. Okay, fine. This is for the 8 months, right? So you can see here there is again a bad kind of prediction only, not that good, right? The error may be low, right? So you can see it captures the trend, right? So when the original gets down, it also gets down. It kind of captures the trend. But for example, in this region, it is still better, right? It is almost near to the blue line, right? So this is a decent prediction. Let us see when we have the overall prediction. Right, so let me just plot another one. So here it is taking 1st of January. So okay, I mean month from 7th to this one. Again, not a very okay. See, if you can see, this is the best prediction, right? On the right hand side. This is annotate. See, this is technically the ideal prediction. This region, you see, the red points actually overlap with the blue lines. Right, this again is a very bad prediction, right? There is such a huge gap between the prediction, right? The error is very high here in this region. So let us now check for the metrics. So see, our RMSA is this. MAPE is some you can actually get a direct view. So MAPE is 8.9%. Usually, if your model can predict within the 10% also, it is considered a very good estimator of the process or whatever time series that you are seeing. So even though the MAE may be having, so mean absolute error, right? So basically your data is giving, so given a particular megawatt prediction, plus minus 2800 megawatt will be the average error that you are getting. So it's a bit on the higher side, but okay, within 10%, the company can at least gauge an idea about what their future demands may be. So mean squared error, mean absolute error, these were just the function. So scikit-learn does not provide a mean absolute error formula directly, unlike a mean absolute error and mean square error. So we need to write our own function. And now an interesting thing, right? So let's say you feel key, okay, this error is too high. MAE and MAPE is high and I want to improve the model, right? So how do you improve that? So the best thing is like we do in our school subjects, right? When we get our results, we see, okay, which subject I got the lowest marks and then, okay, I need to work on this subject. Same thing we are doing here. Look at the best and the worst predicted days, right? So what I'm doing, you can see here PJME test, right? So basically what I do from my test data set, I predicted some values and I had the original values, right? So for each of the test data set, I am subtracting it from the prediction. So let's say my original was, for an example, let's say my original was 26498 and my predicted was 25,000. So the difference of these two will be roughly 16498. So this is how I store the error. So let us just insert a code block so that we can see. Let me just copy this and execute here. Oh, sorry, I didn't execute this. I think that now. PJME error. Okay. Right. So you had 31,439 values. So you can see to just to verify. I should have made verbose as false actually. See, our testing data set had 31,439 values. That means I trained my model and asked it to test on 31,439 values. See, these are the original values, right? These are the true values, right? So when the model trains and applies, what it does internally, it hides all these things, right? It will assume that I don't know what are these values. And so the model has predicted 31,439 values that you can see here. Just a minute. Okay. Right, 31,439 values. So you can see this is the error in the first value, right? Minus 4499. So the original value, was 4499 more than the actual value, right? And then the predicted value, sorry. So the original value was 4499 more than this, right? So you get all the errors here, right? And if you see what I'm doing here, I think I'm sorting this. Okay, sort values in the next column. So for all the 31,000, I am calculating the absolute error. And then what I do, I basically sort the values. Okay, I'm taking the sort values and displaying the top 10. So it says that on 2016, month of 7, that is July, and day of the month is 4, I basically had the original value at this and the predicted value as this, right? So you can check in the database also, this was our original value and this was our predicted value. So the difference between the two is 8,887, 8,587, right? And absolute error is just removing the negative sign. So basically this particular day you had the highest error, 8,578. The next was this particular date. This had 7,349. So what the model, see, this is basically for the system analyst. Now it says that the worst day was this, and basically July 4th is a holiday. Basically it is the US Independence Day, right? Right. So 4th July, since it was an Independence Day, so it was not a normal day, right? It was possible that there may have been functions, the offices were closed, right? So the power consumption was low on that day, right? Because on Independence Day, most of the offices and organizations are closed, so the power consumption is less. It is possible that the previous day was a working day, so the power consumption would have been more, and hence the model predicted this particular value. Second, third worst day is December 25th, right? Of course, it's a Christmas day. So, right, in India, for example, you just take Diwali's example. Every home virtually is with lights and all these going on, right? So, a day before Diwali would have been a very normal day, and the day after Diwali was a very normal day. So, having this data and prediction of Diwali day will always give a very high outlier, right? July 4th again is the fifth worst day. So 2017, again, it's an Independence Day, right? So this is how you take a gauge of the data. Ki why this particular date gave me a high error, and is there a significance here for it? Like just like we have for Diwali and all these things. Diwali will have a shoot up in the electricity, right? Something of like that, of that sort. So worst absolute days, let us see the same thing. Now these are just metrics that you can play with. Okay, let us see now best predicted days, right? So best predicted days are, for example, 3rd of October was the best predicted. The original was 27,705 and you predicted 27,775. Just an error of 69 units, right? So you can see the month of 10 is a very frequent month in the best predicted days, right? Month of 10, month of 10, month of 10. So you can conclude that for October, you are having a very good prediction model by your stat analysis. And now plotting the best. This is an interesting graph, right? So see, in the case of worst, right? I took the worst possible days. You can see how far the model is from this, right? There is a huge gap. And now let us try to plot the best predicted days. So you see the orange is overlapping with the blue. So this is the beauty of machine learning algorithms. When it performs really good, it actually gives you a very accurate prediction. right? So on August 13, 2016, this was the worst predicted day, right? So if you see this day, the dates are same, right? 13th August, 13th August, 13th August. Basically, in the entire day, nothing matched for us, right? So unfortunate. And 3rd October, which was the best predicted day, on the same day, every hour the data actually matched, right? So XGBoost is a very efficient algorithm. So I would recommend whenever you are working on time series or even general classification also, because XGBoost is available for classification as well as time series. You can try using XGBoost because many of the Kaggle competitions also were won by XGBoost application algorithms. So for today, this concludes here. You can use my notebooks and right, I also taken them from Kaggle. You can use and practice again. Try to change some parameters and values. Let us see our training and testing where it was. Just let us go upstairs. Right? So we had a split data of 1st Jan 2015, right? So you can try to tweak around this. Let us give us 4 more months to execute, right? So you can have it, okay, you can give it March, oh, sorry, this will be MAR. So you can try to change the testing and the training values and then see what is the impact on the result. This is the only thing that is in our hands, right? If it had some null values, we would have probably dropped it because we have 1.4 lakh rows for the entire data set. So if we had 12 or 13 null values, either we can do a median replace, mean replace. I think that fill NA is already covered in this FDP. So I think Rathod sir, that should be it for today.
Okay,
Thank
so
you, sir.
yeah.
Yeah. Participants, if anyone is having any query, you can just ask, sir. Okay, so there is no question, I guess. Mayank sir, shall I say share my screen?
Okay, yeah, sure.
Yeah. Thank you, sir. Thank you so much, sir, for valuable time and sharing this again extra knowledge with us, though it was not planned, but still. Yeah.
Yeah.
Thank you so much. It was very yeah, wonderful session that you have conducted. Please accept again this second virtual memento on behalf of us, sir.
Yeah, thank you so much. Thank you.
Yeah. Thank you, man.
So I
Thank you very
got two
much.
virtual mementos I got.
Yeah. So
Yeah.
thanks, man. Thank you very much for accepting this at the last moment.
So, shall I conclude the session, sir?
Rathod sir, I have a feedback form. You can just ask them to, fill it and give their feedback. I forgot to post yesterday. Just a second. This is just a minute. Sony ma'am is also here, right?
Yes,
So
sir.
they
Yes.
can, yeah. You can please fill the feedback form. And thank you, participants, for your time. And this is the form that is just for me as a person so that I can improve the next time when I give such a talk. Always a scope of improvement is there. Uh, okay, I think Rathod sir, then can we sign
Yeah.
out of the meeting?
Thanks a lot.
Yeah.
Thank you, sir.
Yeah.
Yeah, so participants, you may leave the session and we'll meet in the evening at 5 o'clock.
Yes.
Okay.